Good afternoon. Today we're going to work on some extra worksheets from chapter 6. Again, I will always have the recording link for the winter semester as well up available to watch. So I'm going to start trying to throw in some other worksheets for our live class this summer. So today, just a reminder too, as we get started, that everybody responds to the email regarding when you're going to take your midterm. I also adjusted some of the dates, due dates for next week because of Memorial Day. The only thing that's due on Memorial Day is the chapter 4, my stat lab. I pushed chapter 5 to go with chapter 6 on the next week on, I think it's Monday, June 6th. So wanted to give everybody a heads up on that. So we're going to start with 6.1 worksheet number 2, actually on page 521. And I'm going to switch to my paper here. And there it is. So chapter 6, we're still talking about probability, but now we're talking about discrete random variables. Discrete meaning, kind of going back to chapter 1, meaning outcomes that have to be whole, right? So a whole cell phone or a whole computer or a whole person or a whole car. And so that's what we're going to deal with in chapter 6. And expected value. And expected value is actually going to take us back a little bit to when we did the weighted averages in chapter 3. It's the same process. So number 1 gives us some review here. It says determine whether the random variable described as discrete or continuous. So kind of going back to some of what we worked on in chapter 1. It says the width of a desk in a home office. Is that discrete or continuous?
I'd say continuous.
Yeah, continuous. You're right, Lauren. Lo, that's continuous because it is something measured. And the next one is the number of vehicles owned by a family. And that would be, drum roll, discrete because we can only have a whole car, right? A whole vehicle. So let's just jump right in. So number 2 says Nick has $5,000 to invest and will commit the whole amount for 6 months to one of 3 technology stocks. A number of uncertainties could affect the prices of these stocks, but Nick is confident based on his research that one of only several possible profit scenarios will prove true of each at the end of the 6-month period. So we have company ABC, RST, and XYZ. They each have different profit outcomes that could happen along with their associated probabilities. So we need to find the expected profit or loss for each of the 3 stocks. And to do that, we're going to go to our handy dandy stat crunch, which makes it very easy. And I'm fairly sure I don't have these in StatCrunch. So if you'd like to take a minute and go to StatCrunch and put these in, I'm going to share my screen here so that you can see my StatCrunch screen. And I am going to enter in this data here. This is ABC, and that's RST, and that's XYZ. And so they're each going to have their profits and then their probabilities that go with that. And remember, the probabilities have to add up to 1, and they do for ABC. And RST also add up to 1 as well. And then XYZ, they have 4 possible outcomes on this stock. They add up to 1 as well. Okay, so we want to find the expected profit. So to find the expected profit, we're going to do just what we did before in chapter 3, which is going to stat and then calculators and then all the way to the bottom to custom. And we have to do each scenario separately. So we're going to go ABC and then var 2 goes with the ABC probabilities and then hit compute. And the mean is going to be our expected value. So the expected value for company ABC is $770. Now, you might be saying again, 770 isn't one of my profits that's listed for A, B, and C. And that's because this is an overall kind of like the expected average of all the outcomes for ABC, what I think is going to happen. So kind of taking into account that making $800 profit is only 50% likelihood. And then we're going to go and do it again. So stat and calculators and custom. This time I'm going to choose RST and then var 4 for its probabilities and hit compute. And RST only has an expected value of 600. So it's lower. And let's go and do it again for XYZ. And XYZ has an expected value of 730. So now that we have those, we can go to the bottom of the worksheet and answer some questions about those scenarios and their possible outcomes. My live people have any questions? So it says, which is the optimal choice based on expected value? So the optimal choice based on the expected value, which would be these, would definitely be A, B, and C. They have the highest expected value. If Nick is an optimist, which stack would Nick choose? Anybody want to throw out their choice? Which would he choose if he was an optimist? The optimist always thinks the best is going to happen, right? And so Nick is like, ooh, XYZ, I could make $2,000 profit on the stock. I'm totally choosing XYZ. Well, even though XYZ is only 20% likely to have that profit of 2,000, but that's what Nick sees. He doesn't see the other outcomes. If Nick is a pessimist, which stock would Nick choose? And a pessimist looks at the worst case scenario as far as profit with likelihood. And profit with likelihood, he might look at the fact that there's a possibility of losing $400, but he most likely is probably looking at RST as a pessimist, because it looks like he's only likely to make $500 because 80% of the time it's going to be the 500. And so he's probably most likely going to choose RST. So pessimist, RST, possibly ABC. Okay. So number 3 says, the FIFA World Cup soccer tournament has been held every year for 4 years since 1930, except in 1942 and 1946, and possibly 2020. I don't even know if it happened in 2020. The table presents the number of goals scored by each winning term. Oh, it actually did. So it must have happened before everything got shut down. So by the winning teams in 2020. So 3 teams won 1 goal, 2 teams scored 5 goals in each of the championship games. Okay. As of 2020. So these are the winning game, right? By the winning team, how many goals did they score? So find the probability distribution and place it in the table to the right. Okay. So we have to look at the total number of years we have here. So that would be 7, 14, 19, 21 total winning tournaments, right? And then to find the probability of each, we're going to take the individual frequency and divide by 21. So this should look a little bit familiar from what we did back in chapter 2 on our chapter 2 review worksheet. Okay, so 3 divided by 21 is 0.143. And then the next one is 0.190. 7 divided by 21 would be 1/3. So that's going to be 0.333 repeater, 0.238, and 0.095. And ideally, these would add to be 1.0, but we've talked about that before, that sometimes they don't quite work out that way. Number 4 is a good one. It brings up some of our items that we learned in chapter 5 regarding playing craps and playing roulette. And I know that there's a lot of students have confusion on these, and the wording of the outcomes get a little tricky. So this one says, in the game of craps, people bet on the sum of 2 paired die, 6-sided dice. A bet on the roll of 11 is called a yo 11. At the craps table, you will hear people calling for a lucky yo, meaning they won an 11 rolled. The payout for a yo 11 is 15 to 1. So if you bet $1, you win 15 in addition to your dollar bet. This means that if you bet $1 and win, you will receive $1 back plus your 15 from the casino. Okay. So there are 2 outcomes here, right? There is they win, which would be exciting. And if they win the $15, not 16. Their profit is 15. And this happens 2 out of 36 times. And you're probably wondering where we get the 36 from. And the 36 happens, if you go to the worksheet, the worksheet for chapter 5. Let me grab that. So if we look here at the worksheet from chapter 5 that we put together the other day, filling in your table here, right? There's 36 outcomes, and the 5 and the 6 right here is the yo 11, 5 and 6 and 6 and 5. And so it happens 2 out of the 36 times. That means the other outcome is to possibly lose. And if you lose, you lose your dollar bet. And that's going to happen all of the outcomes that didn't give us a winning outcome. So that would be 34 out of the 36. Okay. Now, if I remember correctly, I think we have to put a decimal into StatCrunch. So let's go ahead, and I'm going to share my StatCrunch screen. Okay, and I'm going to save this here for just a minute. And that is going to be 6.1 worksheet number 2. What was that? Problem number 2, I think. Okay. So let's go ahead and, oops, do a new data table here. Okay, so let's go ahead and put in our $15 that we're going to win, our $1 that we're going to lose, and then I think, I don't know if it'll let me use a fraction. Let's try this. I can't remember. I haven't used this enough to remember all the things it lets me do and lets me not do in here. So we're going to go to Stat and Calculators and Custom, and our values are in var 1, and our weights are in, it won't let me choose. So we get to put this as a decimal, and 2 divided by 36 comes out to be 0.055 repeater. And so that means 34 out of 36 comes out to be 0.94 repeater. So we're just going to round this out to 0.056 and 0.94. So it adds to 1. So 0. Oops. It's going to be 0.06 and 0.94. Oh, didn't like that, did it? 0.06. And that's going to be 0.94. Okay, there we go. So now we can go ahead and take calculators and custom var 1, var 2, and compute. And there is our expected value. And sadly, we're expected to lose overall. Let's see. That says 0.04. Why did I not type something incorrectly here? Let's try it again. var 1, var 2, and compute. What did I not type in correctly? So if we did this by hand, let's go back and this is a nice easy one we can do by hand and just see if we can figure out what I'm doing incorrectly here. I think it should be a negative 11 cents. So if we multiplied 15 times 0.06, maybe it's just because I rounded that just made all the difference. So 15 times 0.06, that would be 0.9, and then a negative 1 times 0.94 would be a negative 0.94. Negative 1 times. Wow, it's just that much of a difference. So let's try to put in not rounded values. Just that much of a difference makes a difference from losing 4 cents to losing 11. So let's just make this 0.0, oops, 5555. And then we'll make this one 1, 2, 3, 1, 1. Okay, so let's see. That should give us a more accurate situation here. So calculators, custom, var 1, var 2, and compute. And there we go. So just a little bit of rounding made a huge difference here. So if you use rounding, I'm going to share my, can I go back and share my screen here? So I end up putting my var 1 and var 2, I end up doing more decimals as far as like, because these are repeating decimals, I didn't think it would be a big deal to round up and round down, but it did, because it's really a loss of about 11 cents. So let's go back here. So it's really a loss of 11 cents repeating. So it says, what is the house edge, right, is a percent. The house edge is the percentage of what you're going to lose, basically what you're going to lose as a percent. So 11.1%. Okay. So if you bet 100 on Yo 11, what would you expect to gain or lose? So if I bet $1 up here, I expected to lose 11 cents. So if I bet 100, I'm expecting 100 times that 11 cents, right? Which would be to lose approximately $11.10 out of my 100. And then it says, explain why this is not a fair game. So in chapter 6, we talk, in chapter 5, we also talk about a fair game, right? So a fair game is where it's a zero profit expected. And because this is not a zero profit, so because expected value of the profit is not zero. Okay. So this is giving us some really good intro here to chapter 6 in discrete values. So let's go to page 523. It's another 6.1 worksheet that we can get a couple of these in and a couple of the 6.2. And then I think a few people have some questions on this chapter 6 worksheet, which is fabulous. We'll answer those. So determine whether the table represents a valid probability distribution and explain in each case. So this goes back to what we talked about in chapter 5. They have to add to 1, and we can't have any negative probabilities. So does this add to 1? Without any negative probabilities. So this one is valid. This one is good. What about the second one? So the second one is not valid because there's a negative probability here. And the third one is not valid because it only adds to 0.8. Which is less than 1.0. So number 2 says, the number of customers in line at a supermarket express checkout counter is a random variable with the following probability distribution. So explain why this probability distribution is discrete. Be specific. So we're talking about customers in line. So you can't have half of a customer, right? That seems kind of silly. Find the probability that more than 3 customers are waiting in line. So more than 3 means that we're not including the 3, more than 3. So that would be the 4 and the 5. So that would be 0.1 plus 0.05. So that's 0.15. And then C says, find the probability that X is greater than 2. So that, again, we don't include the 2. So that means we're including 0.2, 0.1, and then 0.05. So that would be 0.35. The next one says, compute the mean of the distribution. Okay, so we have to treat this as a weighted mean. So must treat as weighted mean. Now I might have this in StatCrunch already, but I'm not sure. And I'm going to check my data here. So we can. Okay, so you can see my StatCrunch screen here. This is in StatCrunch, this data set. Now, if you happen to not find a data set in StatCrunch and it's on your review worksheet, then you need to put that in yourself. And usually the review worksheets, I don't have the data sets in there for you. I expect for you all to put those in. So you should be practicing that at home while we go through things. And if you have any questions, I'm happy to meet you on the Zoom and kind of go through practicing with you using StatCrunch, entering your own data. So under outcomes, I put the possible number of customers in line, 0 through 5. And then under probabilities, I listed whole numbers, but really they could just be 0.1, 0.2. Oopsie, that I forgot this doesn't. 0.3, 0.2, 0.1. Okay, this is what they should be listed as. I'm just going to save that. Okay, so I've got my outcomes, number of people in line, and my probabilities, and then we're going to go to stat and calculators and custom. And my variable are the outcomes, and my weights are the probabilities. And there is my mean and standard deviation for the bottom of my page there on page 523. So the mean is 2.1 and the standard deviation is 1.3. And just so you know, grouped data like this and these expected value data, we always treat them as population. So that's why they're using population symbols on page 523. So let's go back to our paper here and interpret this together. So this kind of takes us back to chapter 3, right, on our interpretation. So we expect 2.1 customers to be waiting in line, give or take 1.3 customers. So some good practice there. Okay. Any questions from anyone so far?
I think that part always throws me off because we can't have half of a customer, and we said that up
I
in
know.
part A, and then when we write it out, we're like, oh, 1.3 customers.
I know, exactly. It's like, oh, that's kind of an oxymoron, but we just said one thing and then so yeah. So even though we technically can't have 2.1 customers, we're still going to interpret it that way. Too funny. Okay. So next up is on page 524, some more expected profits. So it says, Lori is a commercial building contractor who will commit her company to one of 3 projects, depending on her analysis of potential profits as shown here. So we have A, B, and C. They each have different profits associated with them, along with the likelihood of the scenarios. Okay. And they want us to find the expected profit, which is a gain or loss for each of the 3 of these. And again, I spoiled you with the data. So if you look it up in StatCrunch, you will see it there. And I'm going to put it here on the screen for you all. So here is A, B, and C on the different projects. So I'm going to suggest that you go ahead and pause yourself for a minute and then try each of the 3 of these, and then we'll be back together to go over them. Okay. Okay, so looking at these averages, let's see if you got, I'm going to do a couple of the last ones here. So the project B, okay. Did everybody get 204,000?
Yep.
And project A was 189,000. And then project C, let's show that one. And that shows 145,000. So back to our paper here. It says, which is the optimal choice based on the expected value calculations? So it looks like we would want to choose project B because they have the highest projected outcome. So Disregard the expected values and consider the 3 project distributions. Which should Lori invest in if she's an optimist? What do you all think?
I thought A, because you're 90% likely to get in the 100,000s.
For A? Okay. So probably, I would think she is going to actually choose C is my guess. Because as an optimist, Lori's only looking at the very biggest profit. So the optimist doesn't ever look at the probability. They're just all excited about the profit. So that's probably why they would choose C. And don't worry, on the midterm, if I give you one of these on the midterm, it's usually this.
Okay.
I'm asking you to find the projected outcomes, and then I'm asking you to use that to make your choice.
Gotcha.
It's just always good to bring up, what about the pessimist? What about the optimist? So if Lori's a pessimist, which one do you think she would choose? And I think for a similar reason that you chose the other one low, I think that we would choose A here.
Okay.
Because as a pessimist, Lori's going to go, oh, the lowest profit is only likely to happen 10% of the time. And so that's probably why she would, the pessimist looks more at the probability than the optimist.
Okay.
Which is an interesting scenario.
Yeah, I had him flip-flopped.
Okay, any questions so far? Let's do question number 4, and then we'll take a break and come back and do some worksheets from 6.2. So question 4 says, David Glenn, the promoter of an outdoor concert, expects a gate profit of $100,000 unless it rains, which would reduce the gate profit to $30,000. The probability of rain is 20%. Construct a probability distribution for the possible profits for the concert and the expected value. So I'd like to write outcome first. So I have 3 columns instead of just 2. So for me, I like to write outcome, and outcome would be rain and no rain. And then the profit associated if there's rain, they said is only about 30,000. And if there's no rain, they could have a profit of about 100,000. And then the probability of each of these scenarios, it says the probability of rain is 20%. So that means the probability of no rain would be 1 minus 0.2, which would be 0.8. So we can go to StatCrunch and start a new table. So if you go to StatCrunch, if you hover here and go down to start new table, then you can add in your data. So we can type in the profits of 30,000, 100,000. I'm not saving this one. I want everybody to practice it on their own, typing in StatCrunch. And then the probabilities are 0.2 and 0.8. Okay. And then we can go to stat and calculators and custom and var1 and var2, and then hit compute. And so it looks like the concert promoter is most likely to have an expected profit of about $86,000. So more likely to no rain than rain, right? And so anybody that's having any graduate parties this weekend, they're all looking at this no rain and rain situation right now too, because my friends are having some parties at their house, and I know it's all week. It's been like, is it going to rain on Saturday or Sunday or not rain? So it looks like that's what the issue they're having here too. So how about we go ahead and pause the recording, take maybe like a 5-minute break or so, come back, and we will work on some worksheets for 6.2. And then I think Lo had a couple of questions on the chapter 6 review worksheet that I'll address as well. Okay, we're back from break and we're going to work on some chapter 6.2 worksheets. I'm going to start with the one on page 531. It's worksheet number 3. Let me share my screen here. Here we are. Okay. So it says, determine whether or not the following probability experiments qualify as a binomial experiment. For those that are binomial experiments, identify and or explain N, S, F, X, P, and Q. For those that are not binomial experiments, explain why not. So we have to make sure that we're meeting the criteria that we have in the course pack. And let's just make sure everybody has looked over that criteria. And the criteria for a binomial experiment is on page 166. So we have to have an experiment that has been performed a fixed number of times. And we're going to identify N, anything in the bold here. And then the trials have to be independent. We have to recognize that. For each trial, there has to be 2 outcomes, either a success or a failure. And we have to identify what those are. And then we have to identify what X is representing as, and X can go anywhere from 0 to N. So we have to show this inequality here. And the probability of success is consistent for each trial of the experiment. It has to be the same. It can't keep changing. Okay. And we have to identify what P is, the probability of success, and what Q is. Okay. So Meyer asked 450 random customers whether they enjoy their shopping experiences at Meyer. Customers can choose from 3 possible responses: yes, no, or neutral. And so we have to decide if it is binomial, and we definitely have an N. So there is a fixed number of trials because N is equal to 450 customers. And it's independent because one customer's response shouldn't affect the other. Success or failure, that's not going to work because there's 3 possible outcomes. So it's a no. You can only have 2 outcomes. So that makes this not a binomial distribution or a binomial experiment. Okay, let's look at B. B says each t-shirt is rated first quality or irregular. Suppose a t-shirt factory has an irregular rate of 3%. A random sample of 100 t-shirts from that factory is selected. The random variable X represents the number of irregulars in the sample. This looks promising. So let's start out. So the first thing is, do we have a fixed number of trials? We do 100 shirts. And each shirt should be independent of another. Should be independent. The third thing is, are there 2 outcomes? So 2 outcomes. So success is first quality. Actually, they are looking at the irregular. So success for us is actually considered irregular. And failure is considered first quality. So sometimes they look at the irregulars because that's what they're counting up. So that's what we're going to consider a success in this case. And then the fourth thing is the probability of success. So P is the probability of success. And they said that that is 30 or 3% of them are irregular. And then Q is going to be 1 minus 0.03, which is 0.97. Also, make sure that you're turning your percent to a decimal correctly. A lot of students kind of go quickly on these and miss those. And P and Q should add to 1. Okay. So that gives us practice recognizing a binomial experiment. That's good. And so next up, once we know we have a binomial experiment, we need to be able to know how to find these probabilities in StatCrunch. And so hopefully you have your StatCrunch open, out and open. We're going to look at these 4 scenarios here. The directions for your TI-84 calculator, if you want to use those are in the course pack. And I think they're the blue pages in the back of your course pack. But I had you write in your course pack, if you were watching my YouTube videos for 6.2, that we're going to go to stat and calculators and binomial, and we're going to enter some things from there. So let's look over our 4 scenarios here, and then we'll go to StatCrunch and find them. So this one here, we have, they all have n equals 18. The probability of success is 0.85 for each of them. And let's just take the wording here and just make sure we all know what we're looking for in StatCrunch. So P of 10 means that probability that the number of successes will equal 10. Okay, at least 14 is the probability of successes as least is greater than or equal to 14. At least means 14 is included. So let's just write that. This one says probably that less than 11. So this is less than 11. 11 is not included. And then D says that probably the X is between 12 and 15, and we are including 12 and 15. So because of the equal there. So let's go to StatCrunch. I'm going to share that screen. Can we see my screen there? So like I mentioned, we're going to go to stat and calculators, and we're going to choose binomial this time. And when it's just an inequality on one side or the other, then we're just using the standard here. When it's in between, so letter D is an in between, we're going to choose the one on the right, but for now we're in the standard. And so we have to put in our N, which is there's 18 in our sample N, and our likelihood of success here, P, we have to change that to 0.85. And then letter A said, what about equal to? So we want to choose equal to 10, and we can hit compute. And we should get 0.0022. So on your sheets, when you show your, for me, I want you to be showing me this right here. So the probability of X equal to 10, parentheses equals 0.0022, because sometimes we're going to know, we're not going to know the X, we're going to know the probability, and that's going to get into chapters. We're going to get into that situation in chapter 7. And so I want to make sure that we're writing them out correctly. So part B says greater than or equal to 14. So we're going to change our inequality to greater than or equal to 14 and hit compute. So we have P, X is greater than or equal to 14, parentheses equals 0.8794. They asked for 4 decimal places. And letter C says X is strictly less than 11, so we have to do a less than 11. And so probability of X less than 11, parentheses equals 0.0027. And now you could have also done less than or equal to 10, because that would be the same thing of not including 11, right? So we should get the same probability. Yep. Okay, and then part D is a in between. So we're going to go click on between, and then it gives me the two between markers. So we're between 12 and 15. Zero 0.5085. So I'm going to just show you what it looks like on my screen. So it could be, these are the four that we just did, and make sure you're giving me the entire probability setup. So I know exactly what you're typing in there is correct. Any questions on those so far?
No, but this next page is pretty much all of my questions from the original list.
Okay, good. So hopefully we can answer them before we get to and then that might help you. So let's look at question number 3 here on page 532. It says, a study found that 1% of Social Security recipients are too young to vote. 800 Social Security recipients are randomly selected to vote. The binomial random variable X represents the number who are too young to vote. So we need to pull out what is NP, the mean and the standard deviation. Okay, and so remember, standard deviation and the mean are found on page 171 in your course pack, those formulas there. So we're gonna pull those out here. So N is the number of people in our binomial experiment, 800. P is a probability of success, and in that case, that would be 1%, so 0.01 are too young to vote. And mean and standard deviation, so the mean is N times P, so that's going to be 800 times 0.01, which is equal to 8. So on average, we're expecting 8 of these 800 to be too young to vote. And then our standard deviation is the square root of NP1 minus P, or NPQ. So we're going to say the square root of, in our calculator, N is 800 times 0.01 times, and you could do in parentheses if you wanted, 1 minus 0.01. And so that should be 2.81. Any questions on that one so far?
Nope.
And then it says, interpret the mean and standard deviation in context of the situation. Okay, so we're talking about these. So when we interpret this mean and standard deviation, it's a little bit different than chapter 3, because this time we're always going to say out of the N, because it's an average out of this particular sample size, right? The 8, I mean, it would be different if we had a sample of 2,000. This mean would be a little bit different. So we'll say out of the 800 recipients, we can expect 8 of them to be too young to vote give or take 2.81, which is again weird because we can't have 0.81 of a person, but that's how it's interpreted. Letter C says, find the probability that more than 12 out of a random group of 800 Social Security recipients are too young to vote. So strictly more than. So probability that X is greater than 12 is, and we're going to find this in StatCrunch. And don't forget to answer this question if we have questions like this on the exam or the review worksheets. Would this be unusual? Explain. So we need to answer that. So let's go to, I'm going to take this back over to StatCrunch. So we're going to stat and calculators and binomial. And this is a standard. And N is 800, right? And P is 0.01. And this is a greater than 12. And we're going to hit compute. And it's 0.0628. And we're asking ourselves if this is considered unusual. And this is not unusual because it's not less than 5%. So let me go back to our paper here. So we talk about standard deviations when we're talking about the mean and when our observation is more than 2 standard deviations above the mean or below the mean. And when we're talking about probability, we're going to use the 5% rule. So this is a no because this is greater than 0.05. So not unusual. Then question, I'll let everybody get that down for just a minute. And then once you get that done, go ahead and take a minute here and look at number 4 and see what you think your response is going to be. Okay, everybody get a chance to look at that. So it says, explain which graph is appropriate for a binomial distribution with n equal to 50 and p equal to 0.75. So if we have a sample size of 50 and a probability of success of 0.75, what would our expected mean be? Because that's what we're going to look for here, right? What's where our center is. So we would expect this to be at, when you multiply those together, I think that comes out to be 37.5. And that would be on this one right here. Any questions on either of those so far? Okay. Okay, so Question number 5 kind of puts it all together here, asking kind of all the overall questions. It says 13.6% of the US population is foreign born. You are going to select 50 unrelated random people in the US and answer some questions about them. So it doesn't ask us to qualify that it's a binomial experiment, but we're going to assume that it has met all those requirements. So N is the 50 people that are unrelated, and the probability of success is 0.136. And it says find the probability at most 4 of the people are foreign born. So the probability that at most, so that means at most is the weird one in our course pack. Make sure that I think the inequalities are on the gold sheets. So let's just check that. They are. So right here on the gold sheets, at most is one that's always hard to remember. At most means we're talking about a less than or equal to. So we're saying at most less than or equal to 4 because we're including 4. So I'm going to let you pause for just a minute, and then when we come back, we'll fill these in together. So go ahead and go to StatCrunch, and you're going to enter in your N is 50 and your probability of success, and then your different situations, and see what you come up with. Okay, so now we're going to put in our number and our sample size of 50. And our probability of success is 0.136. And this first one is at most 4. So we have to change it to a less than or equal to 4 and hit compute. And we get 0.1721 rounded. Part C says, find the probability at least 9 of the people are foreign born. So this is probability of at least 9. So this is a greater than or equal to 9. So now the cool thing is once you have your scenario in, you just have to keep changing the inequality. So greater than or equal to 9 and hit compute. And that's 0.2335. D says, find the probability that between 3 and 9 inclusive of the people are foreign born. So inclusive is the between. So when we click on between, that less than or equal to here, that means inclusive. So that's what we're doing, is the probability between 3 and 9. And this already says 3, so we just have to change that to 9 and hit compute. And we get 0.8397. And then E says, find the probability that none of the people in the sample are foreign born. Would this be unusual? So that's going to be back to the standard equal to 0. So probability of X equal to 0. And that comes out to be 0.00067. We'll round that to. Okay, so let's go back to my paper here. So this is what these look like. If you want to take a minute and write those down, make sure that you have what I have on my paper as well. And E is the only one that had an extra question. It says, would this be unusual? And that's a yes, because it's less than 5% or 0.05. So yes, it would be unusual. It says find the mean and standard deviation. So the mean is going to be 50 times 0.36. And that comes out to be on your calculator. I think 6.8. Checking. And then the standard deviation is that square root again. So we're going to do the square root of n, which was 50, times 0.136, parentheses 1 minus 0.136. And so our standard deviation is 2.42. Again, we get that 2.42. Then it says interpret the mean of standard deviation in the context. So using our story. So in a random group of 50 unrelated people, we would expect 6.8 of them to be foreign born, give or take 2.42 people. And again, to Lowe's comment earlier, it feels kind of weird when you can't have part of a person and we say that, but that is just how it's so that's not a problem. Any questions so far?
Nope.
So that's mainly what I had for today. I'm happy to go through and answer your questions, Lo, on the chapter 6 worksheet if they were not already answered.
I was just talking to you and I had my mic muted and I didn't even realize it.
Oh, too funny. What were you saying?
So on page 541, it's number 7 on the review worksheet.
Let me
I
get
had
there.
my numbers in part A totally wrong and I fixed all of that now that I saw what you just did on the similar question. So I'm better with part A. It's the interpreting that throws me off. The wording of it, just I can't ever figure out how to word it to where it sounds. My mind goes blank. I don't know.
So kind of like what we just did, I would
Yeah.
say out of a random group of 100 children, right? We're talking about
Yep.
age 16 to 17. We would expect blah, 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 your mean,
Yep. Okay.
to be using prescription medication during the last 6 months, give or take, blah, blah, blah.
Okay.
Yeah. So on these in chapter 6, we always kind of have to say out of our sample size, out of a random group of our sample size, because our sample size actually determines the mean, right? So
Okay, that helps.
yeah, that's
And
good.
then, if we were saying describe P9 in words using the context of the situation. So if P were to equal 9.
Yeah. If X were to equal 9,
Oh, yeah,
nine
yeah.
children. Yeah, if X were to equal 9.
Okay.
Yeah. And then D, E, and F are kind of looking at that too. If X is at least 3, if X is between 4 and 11. Yeah.
Okay, that helps. And then my only other question was number 6 on the page right before that. We just had a really similar one to that also in the review worksheet with the 2 graphs. So I just need to find the mean there.
So, yeah, because that's how we would kind of compare them is which one talks about a sample size of 90 with a probability of 0.4 using these 2 graphs.
So I think I just talked myself into thinking this is a trick question because one graph has a label on the y-axis and one doesn't. So I was gonna say it can't be A because there's no label. So I thought,
good one. Yeah, that's just a mistake. That's just a
Okay.
mistake. Good one. Not a trick question, but I do like that. I like that you're being detailed.
okay. I think that's all I had for the review worksheet.
Awesome. Oh, and and a couple other people, while we're bringing it up, let's just talk about number 3. I think this is a good one to talk about too. So while we're on here and we have extra time. Number 3 says you bet $1 on the 31-34 line. So they mark the line here with this little white chip. So when you go to play roulette, you bet on this. This is what the betting possibilities are, but it's actually that wheel that spins. And if we get out our gold sheets, this is what it looks like when they spin the wheel. It's either the European wheel or the American wheel. And these are the different bets using the European and the American roulette. So this one is an American roulette one here. And a line bet, all the definitions are on this page here. A line bet is, it's a bet on 6 numbers in 2 rows. So the one that we're betting on is if we land on 31, 32, 33, 34, 35, or 36, we win. Now you don't win as much as if you were to put your money only on red 34 because you're giving yourself more chances to win. So on this one, it says, it stated that you win 5-1, which means a $1 bet, you will receive $1 back plus your $5 profit, right? So there's 2 outcomes here. You guys want to, I'll kind of walk through this first scenario to make sure he has it set up correct. So what are my 2 outcomes on this line bet?
Win or lose, right?
Yep. So we're either going to win or we're going to lose. And if we win, what's our profit?
Sorry, I'm not on that page.
Oh, that's it. I didn't
Because
hear
we're
that.
getting our $1 back.
Yep. So we're going to win 5 is our profit, right? And then if we lose, what do we lose?
Just our $1.
Yep, just our $1. And then our probability of winning. So there's, remember on the American roulette wheel, there are 38 because there's 36 numbers plus a 0 and double 0. So our probabilities are out of 38. And for StatCrunch, I'll have to put these in decimal form. And for us to win, we have 6 possibilities of winning on this, right? 31, 32, 33, 34, 35, or 36. And then that means the other 32 spaces we would lose. And then the rest of these are similar to what we did in class today and in the workbook, in the course pack.
Oh, I was thinking there were 36 for some reason.
Yeah, so it looks like there's only 36 numbers, but you have one of the worksheets we did in chapter 5, I think maybe we went about
Yeah,
it.
I think that's the one I looked back on an example and I think we used 36 in that. So that's why I did.
Well, that would be 37. So there's
Okay.
36 plus 1. And the European just has a 0. And then the American is 36 plus 2 because there's a 0 and a double 0.
Okay.
Yep. Yep. So that should hopefully support everybody better on that worksheet. Any other questions for me?
Now that might change my, well, that's obviously going to change my numbers once I recompute that. But now my answer to part B was 0.0002. So when it asked if it was a fair game, I mean, it's not equal to 0, but number wise for money, we wouldn't be getting anything back. So I said yes.
If it's not 0,
Okay, so even if we wouldn't get any money back because if we're I guess if we're talking about money, that's why.
Right, yeah, yeah. So yeah, it has to be exactly zero for it to be a fair game.
Okay. I'm gonna have a lot of scribbles on this worksheet, just
That's okay. That's what it's all about. That means you were working hard.
I should invest in some whiteout.
It doesn't bother me any. So I'm going to stop the recording for today.